Welcome to lesson number 6 on percent composition. Our objectives: calculate the percent composition of a substance as well as the percent composition of water in a hydrate. When we look at any nutrition label, we actually are presented with percent composition, and it's listed here as the percent daily value. So for example, if we look at the total fat in one serving size, which happens to be 5 crackers, it says there's 3.5 grams. The percent value tells us what percentage is this 3.5 grams out of the total amount of fat that you're allowed for the day. That's listed down here as 65 grams. And so we take the amount of fat in this one serving, which is 3.5 grams, divided by the total amount that you're allowed for the day times 100, and we get an answer of 5%. So they're saying that 3.5 grams is 5% of the daily amount of fat that you're allowed in one day. So putting it another way, percent composition is the percentage by mass of each element in a compound. And we have a formula listed on table T for percent composition by mass, and that's the mass of the part over the mass of the whole thing times 100. So how do we calculate then percent composition? Well, the first thing we do is we have to get the mass of the whole thing. And that's the gram formula mass that we learned how to do in one of our previous lessons. And then we're going to plug that into our formula and we're going to solve. So let's see an example. What is the percent composition of calcium in calcium chloride? So in this entire substance, I want to figure out what percentage is calcium in that whole thing. So the first thing I have to do is get the gram formula mass of calcium chloride. We look up calcium on the periodic table, round to nearest tenth, 40.1 grams. There's only one of them in my formula, so it's 40.1 grams. Chlorine, there are 2 of them, and the mass is 35.5 for each, so times 2 gives me 71, and then I add those masses together to get my gram formula mass of 111.1 grams per mole. And now I'm going to plug into my formula. So the mass of the part is the calcium here. It's that piece of the whole thing that we're asking about. And then the whole thing, of course, is going to be the gram formula mass that we just solved for. So part over whole times 100. And we're going to get an answer of 36.1%. So calcium is 36.1% of the mass of this entire compound, calcium chloride, which is 111.1 grams per mole. Okay, let's see another example. What is the percent by mass of nitrogen in NH4NO3? So first thing again we do is we want to get the gram formula mass of the entire compound. And so there are 2 nitrogens, so 14 grams apiece. That's 28 grams. Hydrogen is 1 gram, and there are 4 of them. And then oxygen 16 grams, and there are 3 of those. We're going to add this all up, and we get a total gram formula mass of NH4NO3 to be 80.0 grams per mole. We plug into our formula. The mass of the part is the nitrogen. Remember, there are 2 nitrogens, so it's not 14. It's going to be 28 grams. And then the mass of the whole thing, we just calculated out as 80.0 grams times 100, and we get an answer of 35%. So the 2 nitrogens are 35% of the mass of this entire compound. Let's check your understanding. Can you calculate percent composition of a substance? The next thing you're required to do is be able to calculate the percent composition of a hydrate. When we see that word hydrate, we should think of water. So a hydrate is an ionic type substance, and we'll learn more about ionic substances in the very near future, that has water trapped in its crystal structure or crystal lattice. And when we write the formula, it looks like this. It's the compound formula with a dot and then NH2O, where N is some whole number representing how many molecules of water are trapped in there. So for example, CuSO4.5H2O means that there's 5 molecules of water trapped inside this substance. And that is called a hydrate. An anhydrate, an means not, is a hydrate that has no water in it. It's the opposite of a hydrate. The water has been removed. So how does water actually get trapped inside this hydrate, this crystal? The crystal lattice, this is NaCl, which is table salt, has these open spaces in between, and also notice that there are charges, positive and negative. And water is also charged, has charged ends. And so the water kind of gets attracted and gets pulled into the open spaces within this crystal structure. So what happens if you take all the water away? Well, then we're left with the anhydrate, or the anhydrous crystals. And something that you may see in your everyday life are these silica gel packets. These are anhydrous crystals, meaning the water has been removed. And so they'll very readily absorb moisture or water from the air. And they're often packaged with things like shoes or electronics to avoid the buildup of moisture and the production of mildew. So how do we calculate the percent composition of a hydrate? Well, first calculate the gram formula mass of the entire thing. That's the hydrate including all of the water. And then we're going to plug into the same percent composition formula that we used in the beginning of the lesson. So let's see an example. What is the percentage by mass of water in sodium carbonate crystals? So here is a hydrate, and I want to find the percentage of mass of these 10 water molecules in the whole thing. So first thing we do, we find the gram formula mass of the entire thing. And so we look up sodium, carbon, oxygen, and we look up oxygen and hydrogen and water, which equals 18 grams. And there are 10 of those. And I add up the whole thing, and I get a gram formula mass of 286.1 grams per mole for the mass of this entire substance. Next, I'm going to plug it into my percent composition formula. So going back, the mass of the part here is the mass of the water, the 10 water molecules. Well, if oxygen is 16 and hydrogen is 1 apiece, so there's 2 of those, that gives me 18 grams per mole. There are 10 of those, so 18 times 10 is 180. That's the mass of the water, which is the mass of the part that I'm looking for. So I plug that into the top here. Again, the mass of my part. The mass of the whole thing is the mass of the entire hydrated crystal, which we figured out to be 286.1 grams per mole. That's my gram formula mass. And so 180.2 divided by 286.1 times 100 is going to give me a percentage of 63%. That means that the 10 water molecules are 63% of the mass of the entire hydrated crystal, which is 286.1 grams. So let's see an example. What is the percent by mass of water in BaCl2? And then we're going to have 2 H2O water molecules trapped in this hydrated crystal. So first thing we do, we want to figure out the gram formula mass of the entire substance. So barium is 137.3, chlorine is 35.5, and there's 2 of those. Hydrogen is 1, and there are 4 of those. And then oxygen is 16, and there are 2 of those. I add up this entire thing here, and I get a gram formula mass of 244.3 grams per mole. And now I start plugging into my formula. The mass of the part is the mass of the water that they're looking for, these 2 water molecules. So water is H2O, so I'm getting that from the hydrogens and oxygens. And so when I add those together, I get 36 grams. 32 and 4 gives me 36. That's the mass of my part. The mass of the whole thing on the bottom is going to be the gram formula mass, which is 244.3 grams per mole times 100, and I get an answer of 14.7%. So the mass of the water, the 2 water molecules, is 14.7% of the mass of the entire hydrated crystal. So let's check your understanding. Can you calculate the percent composition of water in a hydrate? At this point, you should be able to calculate the percent composition of a substance as well as the percent composition of water in a hydrate.